So I must say, even as the head of digital, when it comes to AI and deep learning and machine learning and artificial neural networks, this topic scares me. And I was quite intimidated, I think, just hearing Ben's achievements. Just it's mind-blowing, I think, just to have him here today. So welcome.
Thanks. It's great to be here.
Let's just kick off and start off around what is artificial intelligence? I think we hear the words artificial intelligence, machine learning, deep learning. Can you give us a brief summary in, like I often say, in like the Davina's dummy guide? What does that look like?
Cool. So I think AI is everything we haven't done yet. So if you looked at like this crazy sci-fi idea of a phone that you could just talk to and tell it what to do, 10 years ago that would have been AI. Now we're like, nah, it's just Siri. But really we tend to think of it as like a broad umbrella term for a whole lot of different sub-disciplines, and it's really just about making machines do intelligent things. But the kind of modern incarnation of this, which is all the ideas around machine learning, which I guess we'll talk more about, is trying to be able to do that from data. So I want a system that, as it gets exposed to more data or more experience with the world or something like that, it gets better at some task that it's trying to solve.
And in my research, trying to sound very smart in this conversation, I discovered that machine learning has different aspects to it, like supervised learning and unsupervised learning. Can you tell us a bit more about that, and what does it actually mean?
In AI, there's this thing we now call good old-fashioned AI, and that's this idea that you've got a whole lot of formal statements about the world. And it's very powerful. You can do a lot with that, but it breaks down with the kind of irregularities that you find in the real world. So the challenge was really that essentially if you're trying to write these kinds of programs to solve difficult problems, like whether it's recognizing a face or translating text or anything like that, it's really hard to come up with the rules of what defines that problem. But on the other hand, it's quite easy to come up with examples. So if I wanted to do face detection, right, the kind of old way of doing this would be I'd have to come up with the rules, like a face has two eyes, over a nose, over a mouth, and then it breaks if someone's head's on the side or if they're a one-eyed pirate. And then you still have to come up with the rules of like what makes an eye. Like how do you describe an eye in an image? But it's really easy to collect millions of pictures of faces and millions of pictures of things that aren't faces. And this was like the first core idea in machine learning. And this is, going back to your question, what we call supervised learning. So the idea here is I can give a whole lot of examples of the thing I care about and of other things. And essentially, instead of me writing the code to solve the problem, I get the machine to figure out the code itself that does that. And there's a few other areas, and the main ones there is this other idea, which is called unsupervised learning. And there you don't know the true labels. So you might have, for example, a whole lot of images, and I don't know what's in them. But what I want my system to do is look at this data and try find some sort of structure in it. And then the third major category, which was very much a niche thing out of the way nobody cared about until about a year or two ago, which is actually a thing I've been working on for a while, is this area called reinforcement learning. And that's about what I think is really the interesting AI problem, and that's about making long-term decisions. So this area, reinforcement learning, is about asking the question of, if I get to make a whole lot of decisions moving into the future, what's the right thing to do? Now, this is a bit further away from kind of widespread application, but the kinds of questions you can ask there would be around getting a robot to navigate in some environment, or getting a computer to play chess or video games, or making long-term business decisions over the next 10 years, or treating a patient who's got a chronic condition coming into a clinic every month, and you want to ask questions like, should we change treatment or get different tests and that sort of thing.
And is this where it kind of leads into that area of deep learning, where it's solving much more complex problems?
So you've got this quite a deep structured model that, and we call it deep learning because it's got lots of components to it, lots of layers, essentially. And what effectively you're doing here is solving what's been a bit of a thorn in the side of machine learning for a while, and that was feature engineering. So if you wanted to classify the difference between, say, a dog and an elephant, and the things you knew about it were the number of legs it has and the number of ears it has, You could take the smartest algorithm in the world or the smartest person in the room, and they'll be useless, right? Because you don't have like the right features to make the distinction you want. But if you just knew its weight, right, then like you don't need to be smarter. Like any dumb algorithm could tell the difference between those things. So the challenge is finding the right features to answer the questions you care about. So I think the easiest way to visualize this is with images, right? So again, in kind of slightly older-fashioned ways of doing machine learning to recognize faces, you would have needed to go and manually write little bits of code that maybe look for ears or look for eyes. Like, and maybe they don't even do it very well, but and you get a whole string of these features, and then you take your image and pass it through those, and now you've got a whole lot of information you can use to make your decisions. But here what you do is you just give it the raw pixels, and it will learn the kind of intermediate level representations that are required to make the decision. So you learn these representations automatically rather than from like as raw data as possible. And that's really the big idea behind deep learning. But it requires lots and lots of data, which is why everything's data hungry these days, because the models are very complicated.
Can you tell us a little bit about that in terms of some real life practical examples of how this could change the way we kind of live in the world, which I think was super exciting?
We've been putting a lot of emphasis lately into particularly looking at problems around education and healthcare. We're building systems that, to learn to solve difficult technical problems, need to be taken through a curriculum that they can learn these skills. We should be able to customize curricula for students as well. So we're looking at questions around personalization of education there, which says if someone's engaging with some educational material and you can learn something about the way they're doing it, you can actually make recommendations for the order in which they should like traverse the material to get a better understanding of what's going on. And then we're also looking at similar kinds of questions in healthcare. As I said, long-term treatment questions like diagnosis of different, say for example, lung conditions from chest x-rays, from blood smears, and also looking at ways to not just improve the diagnoses, but also better understand why those diagnoses are being made, and maybe find places where it would be useful to ask for other information from like either the history of the patient or like other tests and that sort of thing.
What would be the thing that you would say excites you most about this field, and what frightens you?
Probably the same thing. So there's a big question generally about what's called artificial general intelligence, or in some hype sense, artificial superintelligence. So we're kind of at the point now we can take any reasonably focused task and probably automate it to better than human levels. And this is being done like all the time now. As I say, in anything from chest x-rays to playing video games. And now a lot of the challenge is around broadening what our systems can do. So if we can build a system that can solve one problem, can we, without changing anything in the underlying infrastructure, now get it to solve a completely different problem, and then a third one, and hopefully as it does this, it gains more just general experience and expertise, and it finds it easier to solve other problems. So this is kind of the big goal at the moment, is this idea of a broader or more general intelligence. And that's just a fascinating question, because it really ties back to who we are and how we work and how we learn things. But it's also, I think, a potentially frightening a thing to be working on for a number of reasons, that mainly because humans might mess it up.
I know when we chatted, I had cited off this research that I had read about that said the actual net effect of AI on the workforce would actually be a positive one. And you looked at me like, no, not really. Tell me about that, and what are your thoughts?
I mean, the whole aim for a long time has been to try and automate what we used to call in robotics the dull, dirty, and dangerous jobs. Obviously, it's a different kind of problem in a place with a high unemployment, but there are a lot of things that people shouldn't be doing for various reasons. And like, if you can free people up from certain things, they can focus on stuff they really care about. And the example I always like is someone in HR probably goes into HR because they're interested in working with people, not interested in doing infinite paperwork. I also think a lot of the kind of big challenges we face as a society are the kinds of things that work better when you throw more intelligence at them. So for example, there've been projects on trying to optimize things like truck efficiency. And there have been huge gains in these sorts of things, that you can completely bring down the amount of fuel emissions, the amount of petrol these things need, just by running certain kinds of optimization, which is effectively a kind of machine learning. And so I think there's a lot of potential there. On the flip side, I think there's a narrative that's told a lot about how, for every job that gets automated away, another 1.74 jobs get created. And that might, if that's true, which I'm doubtful of, then it's true just in the very immediate future. So the two things people do are physical labor and cognitive labor. And the whole physical labor thing, we've had robots in factories now since the 60s. There's a lot of things, obviously, that are quite difficult, and that takes longer. But a lot of the cognitive work we do is actually, in a way, much easier to solve. There's this thing called Moravec's paradox. It's basically this idea that stuff that we think is difficult is actually easier to automate. So things like some crazy complex thing you do in Excel, we can actually probably automate pretty easily, but walking is quite challenging. I mean, it's very exciting to be working in these things, but like fundamentally, if you automate out a whole lot of these jobs, then the question is, there's just fewer jobs, and what should people be doing? And so personally, I feel that this is a longer-term discussion we need to have as a society about what is the value of jobs. And my personal radical academic view on this is that jobs are immoral and we shouldn't have them. And so to me, actually, jobs are a problem and we should be solving that and not the other way around.
What does that mean, jobs are a problem?
The reality is most people in the world do jobs that are terrible, like either physically, emotionally, psychologically. And if you don't do this thing for 8, 10, 12, 16 hours a day, at the end of the month, you and your family die. That's pretty shit. This is not a thing we should be proud of as a society. We've got this massive problem with unemployment, and we've been struggling to figure out what to do about that. Maybe the correct thing to do is find some way of saying, look, we've got machines that are coming along. Maybe it's 20 years away, maybe it's 50 years away, but we're pretty sure this is coming. In anything we care about, we can get considerably more efficient at whatever it is, ranging from farming to doing taxes. And maybe instead of being scared of that, we should embrace that and say, okay, so if there's a whole lot less work that needs to be done in society, right, what do we do about that? Do we wait for the day when you suddenly get 60 to 80% unemployment happening in the US and riots in the street and then go, oh, we didn't see this coming? Or do we start preparing for it now and thinking about what is the world we actually want to live in, that is the best possible world we could build? If you look at, for example, so I think the biggest employer in the US is driving. And we all know autonomous driving is something that dozens of companies are working on. They keep promising it's 3 years away, and they've been promising this for about 5 years now. But it's very close. And at some point, when you get autonomous driving, then it doesn't make sense for people like Uber to keep drivers around. It doesn't make sense for big trucker companies to keep drivers around, right? So now you're going to put one of the biggest sectors completely out of work overnight, because it makes financial and economic sense. And it's also safer. You've got something like 1.2 million people dying in car accidents every year, right? That's barbaric, but somehow it's okay because it's driving, right? And again, so it shouldn't be an ethical thing to let people drive cars. But now what are you going to do with all these people that make a living from driving?
What do you see as the biggest challenges, I think, for us living in an emerging market, dealing with kind of the same challenges as you would in a developed country where it's almost you've got the leap is just far bigger? Because for me, that is where I think the rubber starts hitting the road in all of these conversations living in South Africa.
I think that a challenge with this kind of automation and bringing AI into the workplace is that it's really your kind of middle-class desk jobs that are most at risk, which means we should be very motivated to try and do something about this. So having said that, I think there's also a lot of opportunities to make things better in Africa. So I've been involved in setting up this kind of network across Africa, and what's been really inspiring is just seeing the kinds of projects people are working on. So we already know the kinds of leaps that like local societies have made with, say, cell phone technology, and not even having to rely on landlines and that sort of thing. But also, apps that you can take a photo of your cassava plants and diagnose if there's diseases, and that sort of thing. I think that kind of thing is very empowering as well. So I think there's that, which is possibly different to the kinds of situations you might see in developed countries, where there's a number of kind of immediate problems that people are dealing with on the ground that you could just basically solve straight away.
You're doing some amazing work with like the deep learning in Durban, and tell us the story and how that became this global forum that actually is leading the way in this.
So I did my master's and PhD in the UK, and it was a reasonable sized network of us that were abroad, and at the time that was really my only option. If I wanted to study further in these topics, I had to go abroad, and then came back with a vision. But you got chatting soon after I came back to a few other, mainly South Africans, that had either studied abroad and were now working here, either at the CSIR or local universities, and then a few other expat South Africans that were now working mainly for Google. And at the beginning of 2017, a few of us jumped on a Skype call, and we thought, no, we need to do something. Let's have a little workshop, and we'll use our own money and fly the other ones that aren't in the country, fly them out here, and maybe over a couple of days, we'd probably find 30 to 50 people who actually would care about this in the country, and just have a chat for a couple of days. And then we decided we would lose momentum, so let's do it right now and commit to doing this year. This was in 2017. And so we decided we'd host this thing at WITS. And yeah, it turns out a few months later, we had an event of 330 people. We had over 750 applications. So we ran for 6 days. It was a hardcore technical week, like a long week. Every day was jam-packed. We had a number of speakers coming out from all over the place. And so it was aimed at master's students, PhD students, postdocs, academics and faculty, and people in technical roles in startups and in industry. So Google gave us a lot of money, and a few other big tech companies, to completely pay for, I think we paid for 60 students from around Africa to come to fly out here. We paid for everything. We've just had the third one, which was our first one outside of South Africa. That was at Singularity University in Nairobi. And there we had about 700 people. And now we've got UNESCO involved. We've got parallel sessions on ethics, on policy. We're trying to get governments involved and open up discussions with governments about the way they should be doing these things. We had attendees from over 40 African countries. And actually, there's a number of other programs we've now attached to this. The one that I'm very excited about, because I run that, is what we call the Indaba X program. It's kind of like the TEDx thing. So we had 13 events last year, and then this year we had 27 events, which is half of Africa. And this included events running in Somalia, Sudan, DRC, Burkina Faso. Name it, we've got stuff going on there. Partially on the back of this, Google opened their first research lab in Africa, which is in Accra in Ghana. Google and Facebook are funding what they now call the most prestigious master's program in the world, which is running in Kigali. I was lucky enough to be able to go teach there for a bit. And these students, some of them have 3 masters or put their PhDs on hold. Now a lot of them are getting jobs all over the world or into PhD programs. The caliber of students is exceptional. And there's a lot of interest now from a lot of the big tech companies. So we're actually trying to push harder now to get our local companies involved in this, because otherwise you're never going to hire a good person ever again with the interest that's being shown and the support that's being given by all the big tech companies. And that's been just incredibly inspiring.
I think that's super exciting to hear from an Africa perspective, and well done on that. When change happens, people often ask, what does this mean for me? And I think if you were sitting in the audience and had to ask yourself that in terms of what does that mean for me, if I work at a bank or I'm working in a job that could potentially have some level of automation or have a machine doing this better than I do, what does that mean? What would your answer be?
There's things to think about on a lot of different levels, what should you be thinking about for your kids, and what should you think about in terms of your own trajectory through your career? And these are hard questions to answer, mainly because the time frames aren't certain. I mean, for me personally, one question that I think is quite useful is, what do you actually get value from in your own life? The two questions that we always get when we have these kind of radical pseudo-socialist type discussions is, what do you do for income, but what do you do for value? And I think a lot of people defend jobs by saying this is what gives people value in life. And I think that's wrong. I mean, it does give people value in life, but I think that's probably not the way to be living. And maybe there's things to be thinking about, like, what would you actually do if you had this free time? There have been more and more companies that are doing things like trying to reduce work hours and that sort of thing, which I think is the right kind of direction to be going in. But not very many people have the ability to enact those sorts of changes. But, thinking about what you'd like to be doing and actually keeping track of some of the changes that are happening in technology is another very useful thing to do. So we often advise, like when we're talking to kids that want to go into various areas of tech, that if at least the present state of the world is everything's driven by computers, they're not completely autonomous, but they do everything. And if you can't tell computers what to do, then there's questions about your own relevance there. So, like, being able to communicate with what's happening in technology and with computers, I think is a very important thing to be able to do. But as I say, for the longer term, I think the questions are more philosophical.
And so let's jump there, because I know you're a faculty member of Singularity University. Do you want to talk a little bit about that and how it relates to AI and what it might mean in the future?
Sure. The idea is there's now chapters around the world. So South Africa is one of the newer chapters. And there's a number of faculty members. I think there's 12 of us at the moment with different areas of specialization. And really the idea is to act as a bit of a bridge between industry and various kinds of disruptors, whether it's in academia or startups or various different places, and actually talk about some of the technologies and different ways of thinking that people are playing with, to, in a sense, try and help people prepare for the future, to think about ways they might embrace different kinds of technologies, and actually just kind of foster better integration of some of these ideas into the real world.
I know one of the burning things, and I'll ask the question and leave you thinking about it for me, but I asked Ben last week when I met him, is that in all the AI, machine learning, deep learning thoughts that we have, is there anything still magical about human beings? Is there something that makes us special as human beings? And is it something that we can replicate? Consciousness, empathy, and I know you have interesting views around it, and all of us, I think, are waiting to kind of see where this goes. So thank you. It was really, really interesting, and definitely got our creative juices going.
It was great to be here, and this is a very cool format, so thanks.
Okay, great. Thanks.